Hey everyone, and welcome to today's lesson about geometric sequences. Let's get started. So, in a geometric sequence, the ratio of any term to its preceding term is a constant value. Make sure you take some time to record that definition. And remember that preceding means the term before. All right. Also, when we're talking about sequences, remember that each number in a sequence is called a term. So when I'm referring to terms, I'm referring to numbers within the sequence. This is very similar to a concept we discussed earlier this year, arithmetic sequences. In an arithmetic sequence, each term in the sequence was separated by a common difference. This is the same concept, except that in a geometric sequence, each term is separated by a common ratio. So, if we look down at the definitions in the box, we can see that a geometric sequence can have a starting value called A, and then a common ratio we call R. A sequence that has a starting value A and a common ratio R will look something like this. You'll notice that since we're multiplying by R every time, I begin to get some exponents because I have that repeated multiplication. So, geometric sequences are exponential functions. All right. Now, there's two ways to write sequences. We have a recursive definition in which each term is based on the term previous to it. We also have explicit definitions where I could simply plug in the term number and find the value for that term. Shown here, the recursive definition, I look at the first value, and then from there, I look at what was that common ratio. Okay? So if I'm writing a recursive definition here, I'm going to refer to this example I have up at the top, where my first term was 3, and then to get from 3 to 12, and then 12 to 48, I am multiplying by 4 each time. So 4 is my common ratio. So to write a recursive definition for my example up top, I would say that my first term, that's a sub 1, is equal to 3. And then for any term after that, I'm going to take the previous term, which is written a sub n minus 1. I'm going to take the previous term and multiply that by 4. And that's for any term that's greater than or equal to 2. Now, looking at the explicit definition, it's similar, but I'm going to use the idea of repeated multiplication. So, for any term, and again I'm going to use this example up top, so for any term, I'm going to take the first term, which in this case was 3, and I'm going to multiply by the common ratio, which is 4, to the n minus 1. Now, if I plug in any term number, I'll find the value for that term. Let's look at a couple examples down below. In example 1, we're simply trying to figure out which sequences are geometric and why. If I look at part A, I can see that I'm multiplying by 10 each time. So this sequence is geometric, and the common ratio is 10. All right, in part B, notice that I'm multiplying by a different number each time, so this is not geometric. Moving right along here to C, you can see that I'm multiplying by the same number every time. I'm multiplying by -1, so this is geometric. And my common ratio is -1. All right, let's get some more practice writing recursive and explicit formulas. If I look down here at example number 2, I'm going to start off with number 7. Okay, so my first term is 7. And my common ratio now is how I get from one term to the next. To get from 7 to 21, I multiply by 3 rather. And to get from 21 to 63, I multiply by 3. And then 63 to 189, again I'm multiplying by 3. So my common ratio is 3. Let's go ahead and use that to help us write our recursive and explicit formulas. Our recursive formula, I start with the first term, which is 3. Oops, excuse me, which is 7. And now I'm going to write for any term, I'm going to take the previous term, a(n minus 1, and multiply it by 3. And that applies for all terms that are greater than or equal to 2. All right, now for an explicit formula, I go ahead and I say for any term, I start with the very first one, which was 7, and I multiply that by 3, which is my constant ratio, to the n minus 1. Hope we're catching on. Let's go on to the next page and try a couple more examples. All right, in example number 3, we've got a bit of an application problem. We've got managers at a clothing store that are creating sequences to show the original price and the marked down prices of an item. We're going to write a recursive and explicit formula for each sequence, and we're going to figure out what the price of the item will be after the 6th markdown. So if I look at the first sequence, I need to find out what the first term is and then what my constant ratio is. So the first term we see is 60, and then to find that constant ratio, common ratio, I'm going to be dividing the second term by the first term, and then the third term divided by the second term to figure out what I'm multiplying by each time. Turns out when I do 51 divided by 60, I get 0.85. If I do 43.35 divided by 51, I get that same number, at 0.85. So my constant ratio is 0.85. Now let's go ahead and write a recursive formula. So my first term is equal to 60. For any term after that, I'm going to take the previous term and I'm going to multiply it by 0.85. For an explicit formula, for any number, I'm going to take that first term, which was 60, and I'm going to multiply it by 0.85 to the n minus 1. Now, if I want to figure out what will be the price of the item after the 6th markdown, okay, so that means I will have done 6 markdowns, which means I need to be looking at the 7th term. Okay, after the 6th markdown will be the 7th term, because 51, that's the first markdown, 43.35, that's the second, the third. So, you know, I need to go after the 6th term to figure out what the 6th markdown was. So let's go ahead and plug that into our explicit formula. So if I do a sub 7, pardon my mistake there, if I do a sub 7, that means I'm going to do 60 times 0.85 to the 7 minus 1. If I plug that in my calculator, I get $22.63. That will be the price of that item after the 6th markdown. This second sequence, if you divide 52 by 60 and then do 44 divided by 52, you find out we get 2 different numbers. So this is not geometric. And in fact, if you look to see if there's a common difference, you can see that I'm subtracting 8 each time. So this is an arithmetic sequence, so we're not going to go ahead and find the explicit and recursive formula because this is not geometric. All right, one more example, and then it'll be your turn. In example 4, I'm given that a geometric sequence has an initial value of 6 and a common ratio of 2. And we're going to write a function to represent the sequence. Well, the good news is that writing a function is the same as writing writing an explicit formula. So if I go ahead and I use what I know about writing explicit formulas, that means I need to have the first term, and I also need to have the common ratio. So to make this like a function, instead of using n's and r's, we're going to use x and y. So remember that a exponential function has the general form of a times b to the x. In this case, our a value is going to be the initial value, and our b value is going to be the common ratio. So go ahead and write y equals my initial value of 6 times the constant ratio of 2, and I'm going to raise it to the exponent, and it's going to be x minus 1, because if you remember when I write the explicit formula, it's n minus 1, so it needs to be x minus 1 to make sure that I'm keeping with the pattern. To make sure we have enough time here, we're going to go ahead and skip the graph, but you know that to graph this function, you need to make a table, -2, -1, 0, 1, and 2. If you have some time after this, I suggest going back and trying to make that graph. So at this point, let's go ahead and try the self-quiz. Pause the video, and then check your answers. All right, folks, on the self-quiz, what's the common ratio for the sequence? You should have found that the common ratio is -9. Make sure you notice that the signs are changing, so my constant ratio is a negative number. It should be -9. Determine whether each sequence is geometric or arithmetic. I'm going to be looking to see if I have a common ratio or a common difference. For part A, this is geometric. My ratio is 4. And for 2, this one is arithmetic. And again, this time my difference instead of my ratio is 4. All right. Question number 3, I have to write a recursive formula for the sequence. So I'm starting with an initial value of 7. I need to find my common ratio. So it looks like from 7 to 28, I'm multiplying by 4. 28 to 112, multiplying by 4. So that means that for the next terms, I need to do the previous term times 4. For an explicit formula now, I'm going to do my initial value. So for any number, the initial value times 4 to the n minus 1. Okay? Now, it also asked me to find the next term of the sequence for my recursive formula. So to find the next term of the sequence, I'm going to do 448 times 4. And that now equals 1792. And for the explicit formula, it asks me to find the 10th term of the sequence. So that means I need to plug in 10 for n. So a sub 10 equals 7 times 4 to the 10 minus 1. When I plug that in my calculator, I find out that the 10th term has a value of 183, oops, pardon my comma, 5008. Well, this answer is just a mess now, isn't it? Let's try that again. 1,835,008. 1,835,008 is my answer. All right, last one. You were to write a function for the sequence, so that means you needed to find the starting value, which was 4, and the common ratio is 8, because 4 times 8 is 32. So my function now is going to be y equals 4 times 8 to the x minus 1. All right, folks, hope you learned a lot, even though I bumbled through the whole thing. Apologize for that. Come to class ready to ask questions.